Welcome to this tutorial on LimitRanges. In this video, we'll explore how to set default resource constraints at the namespace level in Kubernetes. LimitRanges are powerful policy objects that help you manage and control resource allocation for pods and containers automatically. A LimitRange is a policy object that constrains resource allocations per pod or container in a namespace. It serves three main purposes. First, it sets default requests and limits automatically for containers that don't specify their own values. Second, it enforces minimum and maximum constraints to prevent excessive resource consumption. Third, it operates at the namespace level, meaning all pods created in that namespace must comply with these rules. There are four key benefits to using LimitRange. First is automatic defaults, which apply resource constraints without requiring manual specification in every pod. Second, it prevents resource hogging by stopping single pods from consuming excessive cluster resources. Third, it enforces standards to maintain consistent resource allocation policies across your namespace. Finally, it provides namespace isolation, allowing you to control resources on a per namespace basis, which is especially useful in multi-tenant environments. Let's look at the basic structure of a LimitRange manifest. It follows the standard Kubernetes format with API version v1 and kind LimitRange. In the metadata section, you specify a name for your LimitRange and the namespace where it will be applied. The spec section contains a limits array where you define the constraints. Each limit entry specifies a type, typically container, and includes four key fields: default for default limits, defaultRequest for default requests, max for maximum allowed values, and min for minimum required values. Understanding the four key fields is crucial for using LimitRanges effectively. The default field specifies the limit that will be applied if a pod doesn't specify its own limit value. The defaultRequest field specifies the request that will be applied if a pod doesn't specify its own request value. The max field defines the maximum limit a container can request, preventing any container from exceeding this threshold. The min field defines the minimum request a container must have, ensuring every container has at least this amount of resources. Here's a complete example for setting memory limits. This LimitRange named memLimitRange is applied to the production namespace. For containers that don't specify memory values, Kubernetes will automatically set a default limit of 512 megabytes and a default request of 256 megabytes. The maximum memory any container can request is 1 gigabyte, and the minimum required is 128 megabytes. This ensures all containers in the production namespace operate within these memory boundaries. Now let's look at a CPU example. This LimitRange named CPU LimitRange is also applied to the production namespace. For containers without CPU specifications, the default limit is set to 500 millicores and the default request is 200 millicores. The maximum CPU any container can request is 2 full cores, while the minimum required is 100 millicores. Remember that millicores are 1,000th of a CPU core, so 500 millicores equals half a core. Applying a LimitRange is straightforward. Use the kubectl apply command with the -f flag, followed by your YAML file name to create the LimitRange. You can verify it was created by running kubectl get LimitRange with the -n flag and your namespace name. Once applied, all new pods created in that namespace will automatically inherit these constraints. It's important to note that LimitRanges only affect new pods created after the LimitRange is applied. Existing pods remain unchanged. This makes LimitRanges a powerful tool for enforcing resource governance in your Kubernetes clusters.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.